Welcome to Math with Mrs. Bibb. Today we will be solving equations and inequalities by graphing. The solution to solving by graphing for equations is where the graph crosses the x-axis. So make sure you make a mental note of that. If you want to highlight, that would be good, where the graph crosses the x-axis for equations. For inequalities, it's the intervals at which the graph lies above or below the x-axis. And then I have asked you to remember that greater than, or equal to is or, less than, or equal to is and. If you will pause the video and write down, if it asks you to solve, then you are finding the solutions, the roots, the zeros, the x-intercepts. All of those things mean the same thing. Okay, we'll start with example 1. If you will please write down example 1. We're going to solve by graphing. So the first thing we're going to do is find the related function. That means we're going to rewrite the equation. We're going to make it equal 0, like it says here. Make it equal 0. So to make it equal 0, I'm going to move this 5 to the left side. I'm going to subtract 5. So that becomes 0 on the right. This also becomes 0, so you're left with the absolute value of 2x plus 6. And now we're going to replace equal 0 with f of x. F of x equals the absolute value of 2x plus 6. We'll pause just for a second and remind you that we just said that the solution to an equation is where the graph crosses or touches the x-axis. So let's go to Desmos. Okay, I've opened Desmos, so I'm going to go to the graphing calculator. I'm going to type in just the expression that's over here on the right. Maybe I'll type y equals, I don't know. Let's see. Let's try typing f of x and see what happens. Now, I don't want to type f of x since it's not one of my choices. I'm going to type y equals the absolute value of 2x plus 6. And remember, my solution is where the graph crosses. Solution or solutions is where the graph crosses or touches the x-axis. So when I look at this graph just touches the x-axis at -3. So my solution set for this equation is -3. The next one, I'm going to make it equal 0. So I'm going to subtract 11. That makes it equal 0. 4/5 times the absolute value of x minus 1 was not affected. Plus 8 minus 11 is minus 3. I'm going to replace the equal 0 with f of x. Or y, that's the same thing. I'm going to open Desmos. And I'm going to type y equals 4/5 times the absolute value of x minus 1. Click outside of that, minus 3. Okay, so the solutions, -2.75 it looks like, and 4.75. So my solution set is negative 2.75 and 4.75. For the next one, we're going to make it equal 0. Negative 3 times the absolute value of x plus 7, 9 minus 14 is negative 5, I think. Let me know if I'm wrong. And f of x is going to equal negative 3 times the absolute value of x plus 7 minus 5. Okay. Let's go to Desmos. I had that in there yesterday, but it did not save, so that's okay. I'll just type it in again. Okay, so y equals negative 3 times the absolute value of x plus 7, click outside, minus 5. Okay, so I don't see, here we go. Does that graph touch or cross the x-axis? No, it does not touch or cross the x-axis, so this one has no solution. Next, we've switched to a quadratic equation, but we're not going to do this any differently. We're going to make it equal 0. And personally, this is just a personal choice. I want my x squared, my quadratic term, to be positive. So I'm going to add x squared to the other side and subtract 10 to the other side to make it equal 0. So I'm adding x squared and subtracting 10. So I'm going to have 0 equals x squared plus 4x plus 14 minus 10 is 4. Okay, I am going to let you use Desmos, and I'm going to make myself a note at the same time as I'm talking. I'm going to let you use Desmos and find the solutions to this question. So I'm going to make sure that next week, after this is due, we will go over these answers. So I'm writing down example 4. You'll go to Desmos and remember, put f of x in place of 0. You'll go to Desmos and type in f of x or y equals x squared plus 4x plus 4. And then you're still solving an equation, so you're going to find the solutions. And again, I'm making myself a note, so I will remember to find the solutions. And you just put your solutions where the graph crosses or touches the x-axis in a solution set. And if it does not cross or touch the x-axis, then the answer is no solution. Example 5, it already equals 0, but I like for my quadratic term to be positive. I want you to, though, type it in this way, and then I want you to type it in by adding x squared, subtracting 3x, and subtracting 7, and turning that into 0 equals adding x squared, subtracting 3x, and subtracting 7. And I want you to see, do you get the same answer? When you type in y equals negative x squared plus 3x plus 7, and you type in y equals x squared minus 3x minus 7, does it give you a different answer? And then whatever you decide based on that, write down your answer or answers, and we will talk about that. Same thing for this question. You're welcome to type it in like this because it already equals 0. You will probably see me rewrite it every time to look like this. Add x squared, subtract 5x, add 1. Add x squared, subtract 5x, add 1. So you'll probably always see me type this in. If you type this in, see if you get a different answer. And again, I will write this question down and answer this question. This is example 6. We will answer it in class before we do this assignment. We'll make sure that our answers match. Okay, on to number 7. Okay, with this particular question, and again, we've still got that negative in the front again. With this particular question, the textbook makers did not realize that we were going to be able to use Desmos, or that a teacher is going to allow you to use Desmos all the time. And maybe you may encounter a question that only has a table and asks you to find the solutions. Well, we know that in a table where the solutions are whole numbers, we're going to have 0 for the y, because the solutions are the x-intercepts, and that's where y is 0. But if you don't have that, so let me type in this into my graphing calculator so I can come up with a table. And you're welcome to go ahead and find the solutions. And we know Desmos gives us the exact solutions. We don't have to worry about estimating. It gives us those exact solutions. But I'm going to type this in and write down part of a table so you can see what happens and you can know what happens in case you encounter a problem like that. Okay. Let me look at the graph. Okay, so hopefully you can look at the graph as well. It does not cross exactly at -1 or -2. It's between -1 and -2, and it does not cross exactly between 1, 2, 3, 4, 4 and 5. It's between 4 and 5. And I want to show you how you know by looking at a table. So here's those values. -2, y is -3. At -1, y is +3. And I do want you to write this down. Make sure you have this on your paper. So in case you're studying for SAT or you encounter something like this in the future, you can say, oh, maybe we discussed that in Mrs. Bibb's classroom. So, okay, I finished writing down the table. If you'll please make sure to finish writing down that table as well. And I want to show you what happens. If you can recall, 30 seconds or so ago, a minute ago, I said that the solutions were between -1 and -2, and also between 4 and 5. Now, how can I tell that by looking at a table? Well, you can tell where the sign changes, from negative to positive or positive to negative. So if you look here, the sign for the y in the y column, the sign for the y changed from negative to positive. So that tells me my solutions lie between -1 and -2. And then looking down the y, 7 is next, 9, 9, 7, 3, -3. So it changed from positive to negative. So that's how I know that my solution or my graph crosses the x-axis between 4 and 5, because our sign changes from positive to negative. I want to show you another thing that you know by looking at this table. I know where, or close to where, the vertex is of this quadratic. When you look and you see two numbers that are the same, the vertex is going to be in between those two numbers, because these two numbers are reflected across the y-axis. 1, 9 and 2, 9 are reflections of one another across, not the y-axis, across the axis of symmetry. So we know that the vertex would occur between between 1 and 2, because those two numbers are the same. So this would be a solution, and this would be a solution. And of course, you're going to find those exact solutions from Desmos, and we will discuss those in class. For the next one, it says if exact roots cannot be found, then state the consecutive integers between which the roots are located. So you're going to make it equal 0, just like we did before. You are going to type y equals x squared minus 7 into Desmos, and then you're going to tell me between what two integers the solutions are. Now, I believe there are two solutions. If not, we'll discuss that in class. So if you'll find the two integers that the solutions are between, don't find the exact values, find the two integers that the two consecutive integers, if you see that over here, that the solutions are between. Now this last one, I didn't have room, and this would have been the only thing at the top of the next page. So if you will please, you can either flip your paper over and write example 9 on the very back. You've got all that space to do it. Or you can find space on the front and make sure I can really tell that that's where example 9 is, because I'll be looking for example 9. And there is a typo there. That should be 14, not 143. Okay, so it wants me to use a quadratic equation to find two real numbers with the sum of 24 and a product of 14. So I'm going to start with x is the first number. If they have a sum of 24, then if I subtract one number from 24, then that would be the second number. So that's how I'm going to use the sum of 24 to find the solutions. And then the next thing I'm going to do, these two expressions have a product of 143. So x times 24 minus x is going to equal 143. I'm going to distribute 24x minus x squared equals 143. I'm going to make it equal 0. So I'm going to subtract 24x and add x squared. And I'm going to have 0 equals x squared minus 24x plus 143. And then I'm going to type into Desmos y equals x squared minus 24x plus 143. And those two numbers are going to be the solutions, or the roots. So if you will type this into Desmos, y equals x squared minus 24x plus 143, and then fill in this answer. The two numbers are blank and blank. Okay, I look forward to going over the answers to this with you. I hope you have a wonderful day. I'm glad I looked back, because I actually forgot to include solving absolute value inequalities. And so I am going to add 2 more examples. Thank goodness the entire back of your paper is blank. When you have an absolute value of inequality, you're going to make sure it equals 0, or make sure 0 is on one side of the inequality. And then you're going to use an equation just like we did before. We do have 0 here. Oops. We do have 0 here. And we're going to set that equal to y and we're going to type that into Desmos. And then, like I said at the very beginning of the video, less than or equal to, that's an AND problem. And remember, AND problems, when you're putting it in interval notation, look like this with your two values. I'm going to put number, number, or this with your two values based on your symbol. If you have just less than, let me highlight. If you have just less than, then these two values go together. If you have less than or equal to, then these two values go together. That's how your answer will be represented. So as I look at that, my answer is going to be like the blue. Again, the solutions are where the graph crosses or touches the x-axis. So my graph crosses at 1 and 5. And since it's less than or equal to, my answer will be bracket 1, comma 5. Close the bracket. That's the solution to that inequality. Let's do one more example, so you will have 11 examples. So you think about this one as a closed circle here, and you shade everything in the middle. That's what an AND graph looks like. And I apologize that they're not all typed on there, but you all are perfectly capable of adding example 10 and 11 after example 9. And I just wrote 10 again. Okay, so that next inequality is the absolute value of 5/7 x plus 2 minus 3 is greater than 0. So I'm going to make that equal to f of x So replacing the 0 with f of x, I'm going to remember that greater than or equal to are OR problems, and that my OR answers are written in an interval from negative infinity to my first solution, and then you either put a parenthesis or a bracket based on, and we'll do that, a parenthesis or a bracket. Please know, I know that that's not what the answer looks like. Union, parenthesis or bracket based on your symbol to positive infinity, and you'll put that second point of intersection there. So let's grab Desmos and type that in. And that was y equals the absolute value of 5/7, x plus 2 minus 3. Okay, so there's my graph. It crosses at -7 and 1.4. So let's see how to write that solution. Almost think of it this way. Let me move this out of the way. Think of this as your number line, that you have an open circle. You have an open circle here, and let me not use white. Open circle here, shade forever to the left, and an open circle here, and shade forever to the right. I'm going to go back to that previous example so we can talk about that. An OR graph looks like this one that I have just drawn. So my answer is going to be from negative infinity to -7. It is just greater than, so I would put a parenthesis, union 1.4 with a parenthesis to positive infinity. And that would be the solution. I apologize about that. I will upload this video now. Have a wonderful day.